envelope curves.
Okay, no problem. Is it
Next,
visible?
we discuss several comparative static analysis as we
Okay, so these are the comparative static introduction, or beginning of the comparative static results for the cost minimization problem. We have this Lagrangian expression, then we get the first order conditions, and this is the required second order condition. So you are aware of these things.
Ma'am, I did this one. Like, I started this one.
Okay, okay, very good. So, those who started, it will be easier to communicate because, I'll be able to check the results first. So that was my objective. However, we will start from the beginning in the class. So these are the first order conditions, and on the basis of these, you did some numerical exercises, etc., and you are quite familiar with all these first order and the second order conditions. Now solving the first order condition, and if the second order conditions are satisfied, in that case we can generate the values x1, x2 and lambda. X1 is basically x1 star with which is a function of three parameters w1, w2, y. So w1 and w2 are the prices or unit prices of two inputs, and y is the output. This is a cost minimization problem, so output is considered to be fixed. We minimize cost subject to the output constraint. So output that is coming in the final values of the variables x1, x2 and lambda. So these are basically input demands x1, x2, and this is the value of the Lagrange multiplier at optimum. So now what we have to do, how these x1 star changes because of change in w1, because of change in w2, because of change in y. Then how x2 star changes because of change in w, because of change in y, etc. How lambda changes because of change in w and because of change in y. Okay, so for each of the variable x1, x2 and lambda, we have to first take the derivatives with respect to w1, then with respect to w2, and then with respect to y. Okay, del x1 star by del w1 and del x2 star by del w2, these will be the slopes of the factor demand curves, whereas del x1 star by del w2 or del x2 star by del w1, these will give us the cross effects. Okay, and we can also find out del xi star by del y, how the input demand changes with respect to change in output, how the input demand changes with respect to change in output. Now, if the inputs are normal goods, in that case, it is expected the signs should be positive. However, if the inputs are inferior inputs, in that case, there is a possibility that del xi star by del y is negative. So it is not necessary that as output increases, input demand will increase. If input is a normal good, in that case, it will increase. However, if it is an inferior good, in that case, as output increases, you will use less and less of that input, and you will substitute it by more and more of the other input, which is a normal one or superior one. Okay, so all these concepts will come. So let's start doing this thing. Let's start with the entire matter. First, we will find out del x1 star by del w1, del x1 star by del w2, and del x1 star by del y. So three derivatives with respect to x1 star first we will derive. To do so, we will rewrite the first order conditions. So from this point, please start writing. Please start writing. You have to do these things. You have to do these things. So from this point, please start writing. So we are rewriting the first order conditions, putting the optimum values, and while we are putting the optimum values, we are bringing the parameters in the analysis. Optimum values are the functions of several parameters, so we are bringing those parameters explicitly in the equations. So let's look once again the first order condition. It was W1 minus lambda F1 is equal to 0. W1 minus lambda F1 is equal to 0. So W1 will be like that, minus lambda star will be function of W1, W2, Y. And F1 will be also function of two commodities, x1 star and x2 star, and those x1 star and x2 star will be functions of w1, w2 and y. So we are rewriting the equation in this format: w1 minus lambda star, that is a function of w1, w2 and y, into f1. This f1 is a function of x1 star and x2 star. X1 star is function of w1, w2, y, and x2 star is function of w1, w2, y. This is equivalent to 0. Since we are putting the optimum values, we are using equivalent to instead of equality sign, because we are putting the optimum values here. So look at the first equation and check whether you are understanding this, because if you understand the first one, you will understand the rest. If anyone have any question, any query regarding the equation, regarding the first order condition, how we are rewriting the first order condition, please ask me. Otherwise, please proceed with rewriting the second equation and rewriting the third equation, incorporating the optimum values. And optimum values are function of parameters of the model. Parameters are w1, w2, y. Sajid, is it understandable?
Yes, ma'am.
Okay, so all three equations you have written?
Yes, ma'am. I'm writing.
Okay. So just once again, you can look at the second first order condition. That was W2 minus lambda F2 is equal to 0. So W2 will remain like this, minus lambda star function of W1, W2, Y, then into F2. F2 is a function of x1 star and x2 star, where x1 star and x2 star are functions of w1, w2, y. The third equation is y minus f of x1, x2. So y will be like this, minus f of x1 star, x2 star, where x1 star and x2 star are functions of parameters. Once you do this thing, please take the derivative of all these three equations with respect to W1. Please do it on your own and check it from the slide. Once you write these equations, please take derivative with respect to W1. So Panita, you told that you did this or started to do this thing. So please check this thing. If there is any mismatch, please let me know.
Okay, ma'am, just checking.
Those who have already did this thing or started to do this thing, please check the signs, check the values. Please check if there is any mismatch. And others, please take the derivative with respect to W1. Anandarupa,
Yes, ma'am, I'm solving.
understanding the matters?
Yes, ma'am.
Derivatives গুলো start করেছো?
হ্যাঁ, ma'am, হ্যাঁ, ma'am.
করতে থাকো।
Ma'am, it's matching with mine.
Okay, very good. And others who are doing these things got this all three equations? Is it complete?
Yes, ma'am.
Yes, ma'am.
Yes, ma'am.
Very good. Once you complete this thing, please, using the Kremes rule, solve for del x1 star by del w1 first, then del x2 star by del w1, and then del lambda star by del w1. So please check whether you got this matrix multiplied with del x1 star by del w1, del x2 star by del w1, del lambda star by del w1 is equal to minus 100.
Yes, ma'am.
Yes, ma'am, got it.
Very good. And then using Kremes rule, please write down del x1 star by del w1. Denominator, you will find that is to equivalent to h, the
Ma'am,
Hessian determinant.
ma'am, the thing is in the matrix form, won't it be like minus 1, 0?
Minus 1, 0. We are taking the derivative with respect to w1.
Oh, sorry, ma'am. I wrote it wrong.
হ্যাঁ, সেকেন্ড ইকুয়েশনে তো আর কোনো w1 ছিল না, w2 ছিল তো।
হ্যাঁ হ্যাঁ ম্যাম, ওটা ভুল করে আমি ইচ্ছে করে ফেলেছি।
Denominator you will keep as in the form of Hessian determinant, because we know the sign of the Hessian determinant. It is a minimization problem, so h is negative. So we will not disturb the Hessian determinant, we will solve only the numerator. Solve only the numerator. So you don't need to write the format as minus h11. Whatever you are finding, please write that. Whatever you are finding, solving the numerator, you write that value.
Ma'am, I'm getting lambda is minus 1,
within bracket lambda f1 to f2
Look
minus
whether you got this one. And finally minus f2 square. The numerator.
Yes, ma'am, I got this.
Numerator
Yes.
will be simply minus f2 square.
Yes, ma'am.
Those who could complete del x1 star by del w1, please move for del x1 star by del w2. Oh, sorry, I'm very sorry. Del x2 star by del w1. Del x2 star by del w1. So let's first find out whatever values we are getting out of this, and then we will move for w2.
Ma'am, sorry, but I couldn't understand how the numerator is coming f2 square.
You solve this determinant.
Yes, ma'am.
So there will be only, minus 1 into this part.
Yes, ma'am.
Okay. So first you check whether you got this thing or not. First you check whether it has reduced to this part or not. Minus lambda star f22 minus f2 minus f2 0. So এই পার্টটা দেখো যে তোমার এরকম এলো কিনা। ফার্স্টে এটা দেখো। এই ডিটারমিনেন্টটা যখন সলভ করছো,
ম্যাম নেক্সটটা কি f12 বাই h?
Minus 1 to by.
আসছে, একটু সবাই একটু একবার হয়ে যাক, আমি নেক্সটে যাচ্ছি এক্ষুনি বলবো।
Sorry, I had made a mistake. Sorry, ma'am.
ঠিক আছে, খালি তো তোমার মাইনাস 1 ইন্টু ওই পার্টটা আছে।
Ma'am, I am getting lambda into h in denominator.
কোনটায় বলছো? ফার্স্টটায়?
Yes, ma'am.
ফার্স্টটায় ল্যামডা ইন্টু এইচ হবে কেন? ডিনোমিনেটর তো খালি এইচ থাকবে।
একটা lambda কমন যাচ্ছে।
ডিনোমিনেটরটাকে নিয়ে কি করছো? ডিনোমিনেটরটাকে নিয়ে কিচ্ছু করবে না। ডিনোমিনেটরটা এই ফরম্যাটে এসেছে তোমার। ঠিক আছে, সো এই ফরম্যাটটা এসেছে মানেই এটা হচ্ছে এইচ, হেসিয়ান ডিটারমিনেন্ট। denominator will be kept in this format. তুমি একটু চেক করো তো তোমার ডিনোমিনেটরটা এইটা এসেছে কিনা।
Yes, ma'am.
এটা এসেছে তো?
Yes,
বাস,
ma'am.
এটাকে কোনো সলভ টলভ কিচ্ছু করার দরকার নেই। এইটা ডিনোমিনেটরে রেখে দাও। ডিনোমিনেটরটাকে নিয়ে আমরা কিছু করব না, বিকজ আমি তো ওর সাইনটা জানি। আমার অবজেক্টিভ হচ্ছে what will be the slope of the factor demand curve সেটাকে বোঝা। That means del x1 star by del w1 that we will derive. Okay.
Okay, ma'am. Got it.
আর নিউমারেটরটা সবাই অ্যাকচুয়ালি যেটা পাচ্ছো সেটা হচ্ছে মাইনাস অফ এই ফার্স্ট কোফ্যাক্টর, যেটাকে আমি h11 নোটেশন দিতে পারি। আই ডোন্ট নিড দ্য নোটেশন এট অল। ঠিক আছে, মানে আমার এই মাইনাস f2 স্কোয়ার হলেই হলো। So finally, del x1 star by del w1, সেই ভ্যালুটা কি আসছে? যারা করে ফেলেছো ডিনোমিনেটর h, আর কি পাচ্ছ?
Minus f1 f2.
Yes, ma'am. Minus f1 f2.
না, তুমি নেক্সটটা বলছো? আমি এটা
Yes,
তো
ma'am.
মাইনাস f2 স্কোয়ার পেয়েছো তো?
Yes, ma'am. Yes,
Yes,
ma'am.
ma'am.
ঠিক আছে, তাহলে এখানে বেসিক্যালি এন্টায়ার সাইনটা নেগেটিভ হচ্ছে, দ্যাট আই ওয়ান্ট টু সে। এইখানটা তোমরা মাইনাস অফ মাইনাস f2 স্কোয়ার বাই h, এবার মাইনাস মাইনাস ক্যান্সেল হয়ে গেল, সো ইট ইজ সিম্পলি f2 স্কোয়ার বাই h. নাও f2 স্কোয়ার ইজ অলওয়েজ পজিটিভ and h is negative by the requirement of minimization, so del x1 star by del w1 is negative. So please write down the factor demand curve is negatively sloped. Factor demand curve is negatively sloped. এই ফার্স্ট পার্টটায় এখনো কারোর কিছু অন্যরকম এসেছে? গেটিং সামথিং এলস, নট আন্ডারস্ট্যান্ডিং দ্য ম্যাটার, এরকম হচ্ছে?
না মাইনাসটা কেন আসলো?
কোন মাইনাসটা বলো? এই
মাইনাস f2 স্কয়ার। হ্যাঁ
এই মাইনাসটা
হ্যাঁ ম্যাম।
একটা -1 ছিল তো,
দেন পজিটিভ হয়ে যাবে না?
ম্যাম del x1 star by del w1 মাইনাস দিয়ে মাল্টিপ্লাই করলে পজিটিভ হবে, মানে
পজিটিভ হয়ে যাবে।
del x1 star by del w1 টা পজিটিভ হচ্ছে মানে?
no ma'am, that is not
No,
positive. It will be negative only, but
h11 এর ভ্যালুটা কি হচ্ছে? -f2 স্কয়ার
minus f2 square. Yes ma'am.
আর ওর সঙ্গে একটা -1 ছিল তো।
Yes ma'am, ওটা করলে নিউমারেটরটা পজিটিভ আসছে।
পজিটিভ আসছে।
নিউমারেটরটা পজিটিভ আসছে। এখানে তো নোটেশনটাকে দেখো না, এখানে তো -f2 স্কয়ার, এটাই বললাম নিউমারেটরটা পজিটিভ হচ্ছে, এইচটা তলায় নেগেটিভ হচ্ছে, দ্যাট ইজ মেকিং ইট নেগেটিভ।
আচ্ছা হ্যাঁ দেন ঠিক।
এখানে একটা নোটেশনাল ম্যাটার আছে, এটাকে আমি h11 করে ধরেছি, মানে ওই -1টা বাদ দিয়ে, এই -1টা বাদ দিয়ে দিস পার্টিকুলার পার্ট, এটা তো h11, যদি হেসিয়ান ডিটারমিন্যান্টের ফরম্যাটে লিখি আমরা তাহলে দিস ইজ h11. সো ফরগেট অ্যাবাউট দিস নোটেশন। আমি h11 এই ফরম্যাটটুকু লিখেছি বলে এই -1 এর মাইনাসটাকে রেখে দিয়েছি। তোমার একেবারেই এখানে ওপরে একটা f2 স্কয়ার হবে, মানে f2 স্কয়ার বাই h হবে।
হ্যাঁ ম্যাম বুঝেছি।
ঠিক আছে, f2 স্কয়ার বাই h। এবার f2 স্কয়ার ইজ পজিটিভ, h ইজ নেগেটিভ, দ্যাট ইজ মেকিং ইট নেগেটিভ। So it is clear to everybody, the final result for del x1 star by del w1 is equal to f2 square by h, f2 square by h, which is negative, and hence the factor demand curve is negatively sloped. নেক্সট আমাদের অনেকে করে ফেলেছে, এইটা এসেছে f1 f2। যারা করেছো তারা বলছিলে f1 f2 আসছে।
হ্যাঁ মানে পুরোটা হবে -f1
Yes, ma'am. Minus F1, F2.
Yes, পুরোটা হবে -f1 f2 by h,
Yes, ma'am.
পুরোটা হবে -f1 f2 h. So আরেকটু proceed করে নিক। Rest of the students, please check whether you are getting the result -f1 f2 by h. And the third one, del lambda star by del w1.
It was also coming positive.
What is the value? First tell me.
Ma'am, -1.
-1.
Yes, ma'am. Within bracket, lambda star.
No. Why? How there will be lambda star? is del lambda star by del W1. How the lambda star will come here? So first I'll ask rest of the students whether you got the value for del x2 star by del W1, because I want to add some text here.
Ma'am, can you show the previous slide once?
Yes.
Ma'am, in the H12,
H12 yes, হ্যাঁ লাস্টেরটা ল্যামডা আছে ঠিকই বলেছো। H12 yes, Supanita.
yes, ma'am. So, like when we are shifting to the next step, like for del x2 star by del w1, ওটা minus h12 কেন হয়ে যাচ্ছে? আমরা তো ফার্স্টে অলরেডি মাল্টিপ্লাইং 1 minus 1 to the power 1 plus 2.
হ্যাঁ হ্যাঁ, এইখানে তোমার -1 ইন্টু, আর এখানে দেখে নিচ্ছি 0 minus of minus the H12 এই নোটেশনস গুলোকে দেখতে যেও না, বিকজ এগুলো আবার ওই কোফ্যাক্টরস দিয়ে দিয়ে তাহলে করতে হবে। সো তুমি লাস্টে কি পাচ্ছি দেখো, এখানে হচ্ছে -1 থেকে গেল, আর এখানে হচ্ছে 0 আর প্লাস, হ্যাঁ তাহলে -f1 f2 থেকে গেল, তাই না?
এখানে প্লাস f1 f2
হয়ে গেল, পুরোটা প্লাস হয়ে গেল।
ইয়েস ম্যাম, আমার নেক্সট স্টেপটাই প্রবলেম হচ্ছে যে তাহলে তো ওটা f1 f2 বাই h হওয়া উচিত সেরকম ভাবে দেখতে গেলে।
মানে h এর ভ্যালুটা আসছে f1 f2 বাই h, এটা
ইয়েস ম্যাম, হ্যাঁ আমার del x2 স্টার বাই del
f1 f2 বাই h।
ইয়েস ম্যাম, তো তাহলে ওটা তো তাহলে নেগেটিভ হয়ে যাওয়া উচিত।
মানে this will be the value minus of f1 f2 হচ্ছে না, তাই তো বলছো?
ইয়েস ম্যাম।
No, ma'am, it is minus f1.
মাইনাস হচ্ছে
Ma'am, like the determinant value, like not the determinant value, like in the numerator in the first place we are getting minus f1 f2.
numerator is your minus f1 f2।
Yes, ma'am.
তাহলে তাই সেটাই রাখো। If the numerator is minus f1 f2, please write down that minus f1 f2 by h, this is the thing. Okay, so keep it like this, forget about h12 etc notation, you keep it like this.
Yes, ma'am. Can we keep it like this? It's otherwise it's just getting confusing.
Yeah, please keep it
Yes.
like this. I'm telling you not to use the h11 h12 that kind of notation, keep it like
No,
this.
that is okay, ma'am. That I understood. But ma'am, even like when we are calculating the value, এর সামনে তো একটা মানে h1 মানে if we are calculating that to be f12, ওটা তো আমরা একটা -1 to the power 3 দিয়ে মাল্টিপ্লাই করছি, তাহলে that is not তারপর তো তাহলে নিউমারেটরটা is becoming positive, that is okay, but the denominator মানে এখানে তাহলে মাইনাসটা কত থেকে আসছে, that is my entire question, because তাহলে মাইনাস ইনটু মাইনাস তাহলে পজিটিভ হয়ে যাওয়া উচিত।
মানে এইখান থেকে তুমি যখন ওটা ডিরাইভ করছো তখন তোমার ভ্যালুটা কি হচ্ছে সেটা আমাকে বলো।
Yes, ma'am. Like del, I mean, ও মানে নিউমারেটরটা বলবো তো, নিউমারেটরের ম্যাট্রিক্সটা বলবো তো?
হ্যাঁ, মানে তুমি
From-
যখন del x1 স্টার বাই এই যে এইরকম ভাবে যখন তুমি ডিরাইভ করছো তোমার ভ্যালুটা del x তুমি বার করেছো কিসের জন্য যেন বার করলে তুমি del x1
del x2 star by del w1.
সরি এটা ছিল তোমার del x2 স্টার বাই del w1 del
Yes,
x2 স্টার বাই del w1 এর ভ্যালু কি আসছে সেটা বলো।
Minus lambda star f11 minus 1 minus f1 minus lambda star f21 0 minus
তুই 3 নম্বরেরটা বলছিস, সেকেন্ডেরটা বল।
হ্যাঁ, আমি del x2 স্টার বাই del w1 যেটা নিয়ে তুমি কনফিউজ সেটা বলতে চাইছি।
I'm saying that only. থার্ড এরটাতেও তাহলে থার্ড রো কলামে চলে আসবে -100, ওটা তো বলছি না, আমি তো মাঝখানে কলামটা বলছি।
তোমার del x2 স্টার বাই del w1 এত বড় ভ্যালু বের হচ্ছে, মানে সেটা f1 f2 বের হচ্ছে না।
না না, f1 f2 বের হচ্ছে, আমি নিউমারেটরটা বলছি পুরোটা, মানে
ও নিউমারেটরটা তুমি
ডিটারমিনেন্টটা, আমি ডিটারমিনেন্টটা বলছি h1
ওকে
এটা।
ওকে 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 সো ইন দ্যাট কেস এই জায়গাটা -100 হচ্ছে।
ইয়েস ম্যাম।
ঠিক আছে, এবার সলভ করে তোমার কি বেরিয়েছে সেটা বলো।
f1 f2 প্রপার f1 f2 বেরিয়েছে আমার।
প্রপার f1 f2
No, it should be minus F1 F2.
হ্যাঁ -f1 f2
Yes, ma'am.
ওটা একটু চেক করো, ওইখানেই তোমার একটু গন্ডগোলটা হয়ে যাচ্ছে।
h12 সলভ করে তো -f1 f2, বাট ওটার সামনে তো একটা -1 দিয়ে মাল্টিপ্লাই করা উচিত, মানে বিকজ ইটস देयर ইন দ্য ফার্স্ট রো সেকেন্ড কলাম।
উপানিতা, ফরগেট অ্যাবাউট দ্য সাইন, ঠিক আছে, সরি নোটেশনাল ম্যাটার্স। তুমি জাস্ট ক্রেমাস রুল দিয়ে you find out the value for del x2 star by del w1 using the Cremas rule, that is substituting -100 in the second column. Find out del x2 star by del w1, that's all, আর কিছু করো সেইটা একটু চেক করো কি আসছে।
ম্যাম ফার্স্টলি ইটস -f1 f2 প্রথমে।
মানে এটা -f1 f2 আসছে তো তোমার।
ইয়েস ম্যাম।
বাস প্রথমে পরে -f1 f2 আসছে কিনা বলো বাস।
ইয়েস ম্যাম।
ঠিক আছে, তাহলে নিউমারেটর ইজ -f1 f2, denominator is h.
Yes ma'am, that is positive, I understand, but আমার ওই সাইনটাতে একটু প্রবলেম হচ্ছে যে।
হ্যাঁ, আমি তো ওগুলো কিছু বলিনি তোমাদের, বলেছি কি আমি এক্সপ্লেনেশন, আমি তো বললাম আই উইল এক্সপ্লেন।
ওকে ম্যাম, ওকে ম্যাম।
The value is -f1 f2 by h, এইটা সবাই পেয়েছো কি?
Yes ma'am.
Yes,
What?
Yes, ma'am.
Yes, ma'am.
Stop here, আর কিচ্ছু করতে হবে না। Okay, so please add, in general it is not possible to predict the sign of, in general it is not possible to predict the sign of del x2 star by del w1, because if there is n factor model, we don't know whether it is a substitute for x1, whether it is a complementary input for x1. Okay, so depending on the fact that whether it is a substitute, whether it is a complementary, the sign will be determined. So in general, it is not possible to predict the sign of del x2 star by del w1. So have you written this?
Yes, ma'am.
However, please add, however, in two input case, considering marginal productivities to be positive, considering the marginal productivities to be positive, within bracket F1 greater than 0, comma F2 greater than 0, we may consider the sign to be, we may consider the sign of del x2 star by del w1 del x2 star by del w1 is greater than 0, is greater than 0. Okay, so this is assumption based. In general, it is impossible to predict the sign of del x2 star by del w1 or del x1 star by del w2. We will be not able to. In a two-factor model, since we assumed marginal productivities of both the factors are positive within the span of production, within the two ridge lines, you know these things. For that matter, we may consider the sign to be positive. We may consider, on the basis of the assumption, we may consider the sign to be positive. That's all. However, this can be negative as well, you know, because F1 and F2 may not be positive for the entire range. Okay, in the feasible range of production, we are considering or we are assuming these to be positive, and for that matter, we can say that in that case the sign will be positive. Is it now understandable?
Yes, ma'am.
Yes, ma'am.
Okay.
Ma'am, what did you refer to as the feasible range of production?
Okay, I think you are familiar with the ridge lines.
Yes.
So generally the production takes place within the ridge lines.
Okay. Yes.
Okay, so that is the feasible zone. Okay, next is del lambda star by del w1. Yes.
Excuse me, ma'am. If f is negative, ma'am, how we will satisfy the first order condition, because w1
Yes,
minus
for that
lambda f1.
matter, from the very beginning, we assumed F1 and F2 to be positive. Right now, at the beginning, we are assuming. So, since we are assuming this thing, we have set up the entire thing like that. For that matter, we are maintaining that assumption. In the very beginning, I mentioned, you know, both F1 and F2 here we are considering to be positive. Okay. So within the feasible range, it can be positive, you know. We are assuming it to be positive. That means beyond the ridge line, it can be negative. So we are constructing the entire thing in that way. We are not considering the bad in that sense. We are considering, you know, within the range of production, feasible range of production, F1 and F2 are both positive. So in the beginning of the analysis, we have considered these assumptions. ঠিক আছে?
Yes, ma'am.
আচ্ছা, এই ভ্যালুটা একটু বলো তো। Many of you got this value too. So what is the outcome? What you have
F2 is
solved? Lambda star into
ma'am, আগে একটা -1 হবে না?
হ্যাঁ ম্যাম
minus lambda star. আচ্ছা, minus lambda star into
F2 F1
একজন একটু বলো তো প্লিজ, শুনতে পেলাম না।
F2 to 1 minus F1 to 2.
F2 F21
F21
minus
F1 F22.
rest of the students got this value
Divided by H.
divided by H, definitely. All of you got this?
Yes, ma'am.
Yes, ma'am.
Okay, so here also we will be not able to tell something about, in fact, in the earlier case, in a two-factor world, assuming marginal productivity of all the factors to be positive, we got this, we actually predicted some sign. Here we will be not able to say anything regarding the sign of F2, F21 minus F1, F22. If it is a profit maximizing kind of problem, where there is strict concavity, in that case you will be able to predict the sign of this kind of derivative. However, when you are handling with quasi concavity, you will be not able to predict the sign of these F2, F21 minus F1, F22 kind of thing. Okay, and for that matter, it can be both positive as well as negative. Okay, depending on the value. If it is a numerical exercise, we will be able to find out whether the value is positive, whether the value is negative. Okay, so in case of numerical exercise, we will be able to solve for this value, or we will be able to say what is the sign. However, theoretically, when we are doing this thing, this can be positive, this can be negative, this can be positive, this can be negative. Again, don't look at this notation, because here we are considering only the cofactors. That is the problem. Okay, so whatever you got, that's absolutely right. Therefore, I told you to derive your value. You have, in fact, you got this thing, you got this thing only. If you take minus sign common, you will get this one. So if you take minus sign common, you will get lambda star into F1, F22 minus F2, F21. You will, or F12, whatever. Applying Young's rule, you can consider F21 to be F12 as well. So I hope you got this thing.
Ma'am, there was no taking minus sign common.
Sign.
Like
you keep the minus sign with you. Okay, whatever you got, you keep it like that. Okay, that is absolutely fine. So please add this del lambda star by del W1. Please add del lambda star by del W1 can be greater than 0, less than 0. It can be greater than 0, less than 0, depending on the sign of, within bracket, F21, F2 minus F22, F1. Within bracket, depending on the sign of F21, F2 minus F22, F1. So this value can be positive, this value can be negative, depending on the sign of the matter within the bracket. Okay, so all three derivations are complete, I hope. Del x1 star by del w1, del x2 star by del w1, del lambda star by del w1. The first one was negative. The factor demand curve is negative. Here, on the basis of the assumption, we are finding del x2 star by del w1 positive. Okay, del lambda star by del w1 can be either positive or negative depending on the sign of f21, f2 minus f22, f1. So is there any question for this first part? First three equations?
Ma'am.
Yes. Any question? Okay. So next we are moving to the second exercise, that is, we will like to find out on the basis of these equations, these first order conditions, etc. We will like to find out del x2 star by del w1, del x2 star by del w2, and del x2 star by del y. So this kind of derivative I'll take with respect to W2. The same set of three equations, we will take derivative with respect to W2. Okay, so please start doing this thing. Please take the derivative of these three equations with respect to W2. So this time I hope you will be, all of you will be a bit faster. The one component will come with the second equation. In the first equation, there will be no 1. In the second equation, one component will come, 1 minus. Third equation will be very, very similar, only del W1 will be replaced by del W2. So once you get three equations, please write down the equations in the matrix format and please check whether you are getting this. Should I keep the earlier slide, so that your derivation becomes easier, or almost you?
No, ma'am. Can you please keep this earlier slide?
Yeah. Everybody could finish it, taking the derivative of three equations.
Yes, ma'am.
So I think it will be better if I go for that matrix equation so that you will be able to check whether we are getting the same things. So somehow, if you don't get the bordered Hessian determinant, or bordered Hessian matrix, so please check the equations once again, because always we will get the bordered Hessian, the matrix associated with the bordered Hessian determinant. If you don't get it during your exam time or any time, so please check the calculations. So everybody is getting this format?
Yes, ma'am.
Yes, ma'am.
Yes.
Okay, so once you get these, please solve on your own. Don't look at the notation, etc. Just find out del x1 star by del w2, del x2 star by del w2, del lambda star by del w2, and tell me the values. I'll write it in the board, DG board. So I hope everybody got this thing. So I'm shifting to the board, So
ম্যাম আগের স্লাইডটা একবার একটু দেখাতে পারবেন, ম্যাট্রিক্সের স্লাইডটা?
matrix.
Ma'am, I got the values.
Okay.
হ্যাঁ ম্যাম ঠিক আছে।
Yes, del x1 star by del w2. Please tell me.
Minus f1 by f2 by h.
Minus f1 into f2.
Yes, ma'am.
Yes, ma'am. I got this.
Okay.
Second one is f1
F1
square by h.
Yes.
And the last one is lambda star within brackets f11 into f2 minus f12 into f1 divided by h.
Okay. So if you get these values, the second derivative is clearly negative. So factor demand curve is negatively sloped. Regarding the first one, we will use the assumption that both f1 and f2 are positive. And if we do so, And this can be, okay, depending on the sign of f11, f2 minus f12, f1. So everybody is getting these values. কারোর হচ্ছে একটু অন্য কিছু হচ্ছে? Those who could complete these things, please consider the change in y now. If anyone faces any problem, please let me know, because students are doing these things. So at this moment, it is possible that they will present the thing if anyone have any difficulty.
Ma'am, can you please show the slide of the equations?
আনন্দরূপা একটু কি বলছো, বুঝতে পারলাম না, একবার বলবে?
ম্যাম, ওই স্লাইডের ইকুয়েশনের স্লাইডটা দেখালে ভালো হতো, দেখে দেখে করতে।
আচ্ছা, so now we are taking the derivative with respect to y. If you could complete this thing, then please set the matrix format of the equations and check whether you are getting the matrix associated with board adhesion determinant. Here 1 minus will come with the third equation, because that is y minus. Is it complete? The derivation? This
Yes.
equation?
Yes, ma'am.
Yes, ma'am.
Okay. So you are getting this format.
Yes, ma'am.
Okay. So now on your own, please take the derive del x1 star by del y, del x2 star by del y. Once you get the values, please tell me the value. Done? Oyon got the values?
Yes, ma'am.
বলতে থাকো del x1 start by del y.
Ma'am, it's minus lambda f12 f2
Minus lambda. Would you please repeat once again?
f12 into f2
Then
minus f22 f1 divided by division border.
okay, del x2 start by del y.
Ma'am, it's minus ma'am, it's minus lambda f1 f21 minus f2 f11
f2 into
11
and del lambda star by del y. What is the value? Anyone else who got the value?
Ma'am,
Minus lambda into f11 f22 minus f12 square.
Sorry, f11.
Into f22
Yes. Then minus
minus f12 square.
ম্যাম আমার ল্যামডা
lambda square আসছে
কোনটা স্কোয়ার আসছে?
ম্যাম লাস্টে
lambda square.
Yes, ma'am, lambda square.
lambda square আসছে
মাইনাস সাইনটা থাকছে কি থাকছে না?
ম্যাম মাইনাস সাইনটা থাকছে
Yes, ma'am. Minus.
This one?
Yes, ma'am.
Okay. So rest of the students, please check whether you got these things. Then I'll move to the slide, to tell you about the signs, etc. The first two can be positive, the first two can be negative, Positive means the input is a normal or superior input, negative means input is an inferior input. Okay, so everything is possible.
ম্যাম সেকেন্ডটায় আমার আগে এফ
সেকেন্ডটায় আগে কি বলো?
ম্যাম সেকেন্ডটা বেসিক্যালি মাইনাস সাইনটা বার করে নিলে মানে
হ্যাঁ
ল্যামডা স্টার আসছে আর মানে নোটেশন গুলো চেঞ্জ হয়ে যাচ্ছে, ওটাই এসছে।
exactly.
মানে
ম্যাম,
তোমাদের যেটা এসেছে সেটা হচ্ছে ল্যামডা স্টার ইন্টু f1 f21
না
হ্যাঁ
না ল্যামডা স্টার ইন্টু f2 ইন্টু f11 মাইনাস f1 ইন্টু f21।
মানে রিভার্স আছে।
হ্যাঁ মানে জাস্ট মাইনাস সাইনটা বার করে নিলে যেটা আসছে সেটা আসছে।
হুম হুম। অয়ন তাহলে দেখো তো গোলমাল আছে।
No, ma'am, it's same only. They are saying if you take minus inside, it will remain the same.
সেটা বোধহয় বলছে না।
না ম্যাম এইটাই সেম ইকুয়েশন, শুধু ভেতরটা রিভার্স হয়ে যাবে।
ভেতরটা রিভার্স হবে, তার মানে সেম নয়।
হ্যাঁ ম্যাম
মানে আমি যদি এটাকে প্লাস করে দিই তাহলে ঠিক হবে আর কি। মানে দে আর গেটিং দিস ওয়ান।
ইয়েস ম্যাম।
So rest of the students are getting this one for del x2 star by del y. একটু দেখা যাক what I have in my slide. T2. T2. That means, you know, Owen, I think rest of the students are right. The sign, this will be like this.
Okay, ma'am.
Or if I want to maintain the similar construct, I have to write it as minus lambda star f2 f11 minus f1 f21. I have to write that format.
ম্যাম অয়ন ভুল বলছিল না, বেসিক্যালি ব্যাপারটা হয়েছিল যে মাইনাস সাইনটা ভেতরে ছিল, আমরা যে বাইরে মাইনাস সাইনটা নিচ্ছি, আমরা যদি মাইনাস সাইনটা ভেতর থেকে বার করে নিই তাহলে সামনে ল্যামডাটা প্লাস হয়ে যাচ্ছে আর ভেতরে যে নোটেশনস গুলো আসছে সেটার অর্ডারটা চেঞ্জ হয়ে যাচ্ছে, আর কিছুই হচ্ছিল না।
Some students said that they got this one. Just you check if whatever the right thing, please write down that.
ম্যাম আমি আগে ভুল বলেছিলাম, ও ঠিকই করেছিল।
ও তাহলে সেটাই তো জিজ্ঞেস করছি, যেটা ভুল তার মানে আগেরটা ঠিকই ছিল, ওইটা ঠিকই আছে। তাহলে মাইনাস ল্যামডা স্টার দিয়ে লিখছি, যখন লিখে ফেলি f2 f11 হবে আর এখানে হবে f1, এটা তো
f21
f21 yes. So finally, these results are there with all of you.
Yes, ma'am.
Okay. Okay, so I like to add a few points. All these three values can be positive or negative. Okay, as I mentioned, these values can be, all of these can be positive or negative. Okay. So the signs can be anything. Okay, so finally, please look at the slide. For the last relationship, del lambda star by del y. Okay. Lambda we interpreted as del C by del Q. Can you remember? Lambda we interpreted as del C by del Q. Interpretation of lambda. Okay, so this was the interpretation of lambda. So lambda can be interpreted as marginal cost, change in cost due to change in output. Can you remember this one? Yes or no?
Yes, ma'am.
Yes, ma'am.
Okay, so that I am putting here. So it is del lambda star by del y. So it is change in MC due to change in y, change in marginal cost, change in incremental cost due to change in y. So if we replace lambda or lambda star by the idea of it is change in cost due to change in output, so that interpretation, if we use these del lambda star by del y, can be presented as del MC by del y. Okay, so and you got the value, etc. You got the value, etc. So here, change in marginal cost due to change in y, that can be positive, that can be negative. Change in marginal cost due to change in y, this entire matter can be positive or negative. Now, if it is a profit maximization kind of exercise, in that case, unambiguously we can state that f11 f2 minus f12 square, the matter we are getting, already you got it, f11 f22 minus f12 square in the last equation. Okay, the matter you got in the last equation, this will be positive. If it is the profit maximizing exercise, unambiguously we can state this to be positive. This, in fact, this is the required second order condition there. So although in case of profit maximization we stated f11 f22 minus f12 square positive, following the strict concavity property of the production function for cost minimization, the strict concavity property is the sufficient condition, not a necessary condition. The only requirement is quasi-concavity. That is the concavity of level curves. That is, in this context, we have to bring the restrictions in terms of strictly convex isoquants. Thus, marginal cost is not necessarily a rising curve. Marginal cost is not necessarily a rising curve. If it is a profit maximizing kind of exercise, always we have to consider the rising MC. However, if it is a constraint cost minimization problem subject to output constraint, the way we are getting it, del lambda star by del y, which is equivalent to del MC by del y, change in marginal cost due to change in output. or this is equivalent to say del square C by del Y square. Rate of change in marginal cost, rate of change of the cost function. Change in MC means rate of change in the cost function. Okay. So that may not be rising always. Okay. Or the MC may not be rising always. When we are taking the derivative of MC with respect to Y, that may not be rising always. Okay. Because here we are considering quasi-concavity of the production function, not strict concavity of the production function. That is, the rate of change of marginal cost function with respect to a factor price is equal to the magnitude of the output effect for the factor. Output effect for a factor can be negative as well as positive. Output effect for a factor can be negative as well as positive. Okay. If X1 is an inferior input, as W1 increases, the marginal cost curve will shift down along the whole range of X1, along the whole range where X1 is inferior, and that will indicate del X1 star by del Y less than 0. So all these possibilities are coming. In case of profit maximization, this problem was not there. However, here it is possible that del X1 star by del Y is negative, and for that matter, that is, if the input is inferior, in that case marginal cost curve may shift to the lower direction when the average cost curve is rising. When the average cost curve is rising, the marginal cost curve may fall like this. Marginal cost curve may fall like this. Though average cost is rising, MC is falling. Okay, so this can be the context. This can be the context. This possibility is also there. When we are considering this kind of sign, del lambda star by del Y can be positive or negative. In other words, del MC by del Y can be positive or negative. That is incorporating the fact that the concerned input may be normal or superior, or it may be inferior. It may be normal or superior, or it may be inferior. Okay. So that context is also there. That possibility is also there. So it is a broader exercise, In case of profit maximization, we got a different mechanism, In case of constraint optimization, when we are deriving the factor demand curve and analyzing all these things, considering the change in cost or change in input demand due to change in Y. Okay, this possibility we are considering in this broader context. This may be negative, this may be negative, and that is accommodating the fact that, or bringing the fact that del MC by del Y, that can be negative as well. In general, we consider del MC by del Y is positive. However, if the input is inferior, or however, if the context is del X1 star by del Y is negative, in that case, del MC by del Y, that will be also negative. So this issue is coming in our analysis. This issue is coming in our analysis. One more thing I like to tell you, like profit function, when we derive the del Xi star by del Wi kind of thing, like profit function, here also we can consider the reciprocity relationship. Already the del X1 star by del W2 and del X2 star by del W1 are with you. So please check whether these two values are same or not. Del X1 by del W2 and del X2 star by del W1. Please check the derivatives and tell me whether these derivatives are equal or not. Del X2 star by del W1, that is still with me. Sorry, del X1 star by del W2, that is still with me, minus F1, F2 by H. Would you please check once again What is del x2 star by del w1? Are you getting the same one?
Yes, ma'am.
Yes,
Yes,
ma'am.
ma'am.
Yes, ma'am.
Okay, so the
Here,
similar kind of reciprocity relation which we discussed in context of profit maximization holds here. However, the conditions are not identical with the profit maximization case. For cost minimization, the optimum input demand is given by x1 star as a function of w1, w2 and y. Output is coming here. Whereas in the profit maximizing exercise, P comes here. P comes here, the price which we consider to be constant. This P comes here. Okay, so though we will be able to show the same or similar kind of reciprocity relation here, if we ask what is the difference between the two, the difference is, here xi star is function of w1, w2 and y. In case of profit maximization, that's a different unconstrained optimization technique, and there the parameters are w1, w2 and p. Okay, so please keep all these points in your mind while you are doing all these things. You are finding all these derivatives, etc., analyzing these things. Please take care of all these points as well. Okay. Okay, and this is also an interesting result. This is also an interesting result. Del lambda star by del wi, that is equal to del xi star by del y. Del lambda star by del wi, that is also equivalent to del xi star by del y. Okay, so would you please check this thing? Would you please look at your derivatives and please check whether you are getting this relation or not? That is del lambda star by del w1 is equal to del x1 star by del y.
Yes, ma'am.
Okay, so if
yes,
I
ma'am.
compare these two things, we have here del lambda star by del w2. So we have this one and we have this one. Okay. So the results are similar. Whenever you have F12, that is equivalent to F21 by Young's rule. Okay.
Ma'am, I have one question over here.
Yes.
Ma'am, I got a value which is equivalent for both, but over here there is one minus extra for del x2 star.
Okay, so there was a lot of confusion regarding this particular derivative, you know. So I said something, later I changed, you know.
This will be only lambda star, not minus. Even I am not.
Yes, ma'am.
Okay, so why you are not telling when, I tried to,
Because even I was confused with this, right?
Yeah,
Yes.
like I like did it again, and then even I was confused and not sure.
is it now fine? Because I am also, surprised why the values are differing, because, always all these things will be same. Okay, I hope now it's fine.
Yes, ma'am.
Yes, ma'am.
So this is the right answer, because otherwise the reciprocity relation also is not holding. Okay, so I changed everything, and then somebody told me that she made a mistake, and I again changed the signs. So I think this is the final answer. This is the right answer for del x2 star by del y, because that is absolutely matching with del lambda star by del w2. Okay, so do anyone have any doubt? Please clear all the doubts you have. Otherwise, you will get a lot of confusion. So this condition holds. This condition holds. So both for del lambda star by del w1, you will get del x1 star by del y, and del lambda star by del w2, you will get del x2 star by del y. So this reciprocity relation is also valid. This reciprocity relation is also valid.
Ma'am, can you show the previous slide once? The one with the graph.
Yes.
Yes, ma'am. Thank you.
Okay. So this is all about the comparative static results, the reciprocity relations, etc. So now you have to practice the things, whatever in question, both in the written test as well as the viva, depending on what component we are changing, you have to find out the necessary relation, and you have to interpret it logically. Sometimes we will get unambiguous sign, sometimes we will not get unambiguous sign. Okay, and when now your task will be to compare the results, what you got from the unconstrained optimization, the result which you are getting from constraint optimization. So in the context where it is possible, please compare the results and check the matters, what is happening here, what happened in context of unconstrained optimization, so that you feel that it's a flow of the same thing. When we are putting a constraint, the things are changing like this. When there was no constraint, the things will become like this. Input demand can be derived using a constraint, input demand can be derived without constraint. Without constraint, we will get a factor demand which is a function of prices of the factors and the price of the commodity. With constraint, we will get the factor demand which is function of input prices and the output. So all these things are there. So please go through these things perfectly so that there is no confusion. One more thing I need to discuss, that is the elasticity of cost curves in the short run and in the long run. Elasticity of the cost curves. We discussed this kind of concept, when we did our profit maximization exercise under unconstrained optimization technique. Can you remember we discussed about this kind of thing, elasticity kind of thing? Forgot the thing? Just okay. So can you remember we discussed this thing? The short run factor demand curve and the long run factor demand curve we discussed in context of profit maximization.
Yes.
Yes, ma'am.
Yes, ma'am.
Okay. So in case of profit maximization, bringing the short run, long run, we discussed something related to the elasticities. We derived this kind of thing. The long run factor demand curve is flatter than that of the short run factor demand curve. So we discussed this kind of thing. Short run, long run, and the issues related to the elasticity, etc. So here we will like to say something about the elasticity of the cost curves in the short run and long run. So we consider the model with n factors of production. We consider a model with n factors of production. Okay, so here we are using the vector notation. This X indicates actually the bunch of inputs, n inputs. X indicates the bunch of n inputs, the entire set of n inputs. W indicates the entire set of n factor prices, which represent the factors and their costs respectively. The fundamental identity relating the long and short run marginal cost functions is how we are relating the marginal cost functions of the short run and long run, bringing lambda in our analysis. Already, we proved that, we checked that lambda is equivalent to marginal cost. So in terms of the Lagrange multiplier, in context of cost minimization exercise, we may present lambda as representative of marginal cost. Okay, so we are writing the lambda values for the short run and the long run. We are writing the value of lambda for the short run and the long run. Okay, so for every short run marginal cost, there will be a point where it is cutting the long run marginal cost, or long run marginal cost intersects the short run marginal cost, whereas long run total cost and long run average cost are envelope curves. Long run total cost curve envelops the short run total cost curves. Long run average cost curve envelops the short run average cost curves. Long run marginal cost intersect the short run marginal cost curves. So for every short run marginal cost, there is a point where it is cutting the long run marginal cost curve. Can you remember this? Actually, we derive the long run marginal cost curve in that way.
Ma'am, there is no intersection actually, ma'am. We take the point where the intersection of LSE and SSE, that point of SMC to equate with LMC.
There is no intersection, first of all, between LSE and SSE. At the point of tangency,
tangency, yes, ma'am.
Yes, at the point of tangency between LSE and SSEs, that is when the firm is selecting a particular plant size, optimum plant size, for that typical short run plant. If you draw the marginal cost curve, you will find that marginal cost curve is intersecting the long run marginal cost curve. For every optimum plant size, the short run marginal cost curve or the short run marginal cost curve will intersect the long run marginal cost curve at the corresponding point of tangency between the SSE and LSE. Can you remember this?
Yes, ma'am. Yes, ma'am.
So that I am telling. For every short run marginal cost curve, there is a point of intersection between short run marginal cost and the long run marginal cost. Actually, this point of intersection corresponds to the point of tangency between SSE and LSE. Okay, so if you can remember this, so we can generate these equivalents. The fundamental identity relating the long run and the short run marginal cost function is given by star is indicating the long run. Long run marginal cost is a function of entire W vector. and y, all the input prices and y. Whereas short run marginal cost is a function of the prices W1 to Wn minus 1. Why? Because at least one factor should remain constant. If I consider the nth factor remains constant, it will be a function of W1, W2 up to Wn minus 1, comma, Xn star. Xn star is the input which we are keeping fixed in the short run, which we are not varying in the short run, which we are keeping fixed in the short run. Okay. Actually, this corresponds to the typical plant size. The typical plant size, plant size we are considering. So in the long run, the plant size is variable. However, in the short run, the plant size is not variable. So, the nth component is fixed. This nth component is a function of, again, W1, W2 up to Wn and y. And there will be additional y component like the long run. So the difference between the short run and the long run will be, in case of long run, all the factors of production are variable. So lambda star, or the marginal cost, will be function of W1, W2 up to Wn and y. Whereas in the short run, it will be function of W1, W2 up to Wn minus 1, comma, Xn star. The input we kept fixed in the short run and y. Lambda s is the short run marginal cost function derived from cost minimization when Xn is a parameter along with y. Okay, Xn is a parameter along with y. Okay, so in case of the short run marginal cost curve, along with y and W1 to Wn minus 1, Xn is a parameter. Differentiating the fundamental identity, if I differentiate it with respect to y, we get this result, del lambda star by del y in the left hand side. Here, del lambda s by del y plus del lambda s by del x naught into del xn star by del y. So please check whether you are understanding this derivative format, whether you are understanding equation number 1. When we are taking derivative in the right hand side, whether we are getting this value. Remember, xn star is a function of w and y. Xn star is a function of w and y. Is it okay? Is equation 1 okay? Please look at the equation. If there is any confusion, please ask me. Next, differentiating the identity with respect to Wn, we get del lambda star by del Wn. Why I'm bringing Wn? Because Xn is the constant factor. Del lambda star by del Wn, that is equivalent to del lambda s by del xn into del xn star by del Wn. Xn star is a function of all w values and y. So when we are taking the derivative with respect to Wn, we are getting this component. So what we can write, or we can rewrite equation 1 as del lambda star by del y is equivalent to del lambda s by del y plus del lambda star by del Wn. I am repeating, del lambda star by del y is equivalent to del lambda s by del y plus del lambda star by del Wn. So if I take the difference, del lambda star by del y minus del lambda s by del y, that will be equivalent to del lambda star by del Wn. Okay, so up to this you got it? Is there any confusion with equation 2, equation 1?
No, ma'am.
Okay. Next, what we are telling that, we discussed about this relationship. Del lambda star by del Wi is equivalent to del xi star by del y. Okay, today we discussed this thing. Del lambda star by del Wi is equivalent to del xi star by del y. Okay, so using that property, we can say that del lambda star by del Wn is equivalent to del xn star by del y. Del xn star by del y. Okay, so in place of this, in place of this, we will put this is equivalent to del lambda star by del Wn. Now we will replace del xn by del y in that place. Okay, and writing this in this format, del xn star by del y whole square divided by del lambda star by del Wn. Okay, so would you please write down these equations in your copy, because otherwise, it may be complicated. So please write down first del lambda star by del y is equal to or equivalent to del lambda s by del y. Plus del lambda s by del x naught into del xn star by del y. Then please write down the second equation. I hope all of you could write it. Then write down the third equation. Del lambda star by del Wn is equivalent to del xn star by del y. Substitute 3 in 2. Are you getting equation number 4? If you get equation number 4, please confirm. Otherwise, I'll check it. পৃথ্বীরাজ, রৌনক, অনুরাগ পাওয়া যাচ্ছে ইকুয়েশন নাম্বার 4?
Yes, ma'am, checking.
Yes, ma'am.
Yes, ma'am.
Yes, ma'am, got it.
Got it?
Yes, ma'am.
Yes, ma'am.
কোনো কনফিউশন নেই তো? আচ্ছা, if you get equation number 4, আচ্ছা এবারে দেখো the numerator of the, এখানে তো আমি del lambda star by del y minus del lambda s by del y ভাবছি in the left hand side, del lambda star by del y minus del lambda s by del y, that is in the left hand side. So in the right hand side I have this element. Numerator is a square, and for that matter actually we did all these steps to bring a whole square in the numerator. So, you know, the numerator is positive, the denominator is unambiguously negative, because the factor demand curve is always negatively sloped, as we got from our earlier result. So, this element is negative. This element is negative. Okay? This can be equal to 0 under certain context. If del xn star by del y, that is equal to 0, in that case it can be 0. However, it cannot be negative. It cannot be positive. This element cannot be positive. Okay? So, equation 4 shows that the slope of the long run marginal cost function differs from the short run marginal cost function by a non-positive amount, and thus del lambda star by del y minus del lambda s by del y is less than equal to 0, or we can write del lambda star by del y, that is the long run marginal cost, less than equal to short run marginal cost. The long run marginal cost is less than equal to short run marginal cost. Equation 4 also shows that the difference between elasticities of the long run and the short run marginal cost functions varies directly with the size of the output effect and inversely with the slope of the factor demand. So if I take the difference, we will have this value. Now the numerator is nothing but the response of the input with respect to change in output, square of the response of input with respect to change in output. So the difference, you know, difference between the elasticities of the long run and the short run marginal costs is proportionally related to the output effect, size of the output effect. This is the output effect, and inversely related with the slope of the factor demand. In the denominator, we have the slope of the factor demand. So this difference inversely related with the slope of the factor demand, whereas it is proportionally related or directly related with the size of the output effect. As output changes, how the input demand responses. As the output changes, how the input demand responses. And since here we have the square, it will be positive, you know. So MC function varies directly with the size of the output effect and the inversely with the slope of the factor demand. Okay, so this is all about the comparative statics, which we generally discuss in context of production function, cost minimization context, output maximization context, etc. Any question or any clarification I need to give you? Here I have written one more thing, Young's rule and envelope curve, though I didn't discuss about envelope theorem. Envelope theorem, the idea of envelope curve I discussed, however, I didn't discuss about envelope theorem. Okay, so this part is only left, envelope theorem. Without envelope theorem too, we can state this result because already we derived this result. So do anyone have any question? Or please go through these things. I think it will be comfortable if I go for one more class. That class will be 1 hour. I think 1 hour class will be more than sufficient, So that, if anyone has any problems while you are going through this thing, I'll be able to take care of this thing and I'll discuss the envelope theorem. That is 3 slides content, and it will not take much time. So half an hour we can keep for the envelope theorem and half an hour for clarifying your queries, etc., regarding the entire optimization process. The syllabus is more or less complete. Just I have to explain envelope theorem, that's all. If anyone have any question, any query, otherwise I'll close the meeting.
And when is the next
so
class?
we will be having only one division class, or can we have one more also?
Just a minute.